In this lecture, I will discuss what we mean by position vector or radius vector. Let us construct a coordinate system. O is the origin, x-axis, y-axis, z-axis, and consider a point P here, and let us join P to the origin, and we have a vector R, which is actually OP. So OP, which we call vector R, is defined as position vector of P with respect to O. Note that the arrow sign is towards the point whose position vector we are writing. Let us consider another point Q, and let us define this vector OQ as vector R prime. So OQ vector, which is vector R prime, is the position vector of Q with respect to O. So again, the arrow is directed towards the point Q whose position vector has been written here. Now let us join P and Q. Let us define a vector QP. So QP, and let us call it capital vector R. So this capital vector R or QP is the position vector of P with respect to Q. Now let us apply triangle law of vector addition to find out the relation between the three position vectors. And it is obvious that vector R prime plus vector R is equal to small vector R. So capital vector R is equal to R minus R prime. Now this is a relation that is widely used in physics. It is a very important relation, and I will give example in this lecture regarding where it is used. So example, let us consider a point Q where a particle is there which has a charge Q and whose mass is m. Now we wish to find the effect of this point in terms of its gravitational pull and electrostatic influence at some other point P. Let us join Q to P. Now the position vector of the point P with respect to some point O, which we take as origin, is say vector r. This is x-axis, this is y-axis, this is z-axis, and this is the position vector of the point P with respect to origin, and this one is the position vector of the point Q with respect to origin, which is vector r prime, and therefore this is capital vector R, and we have the relation capital vector R equal to R minus R prime. Now the effect of this mass m at point P is obtained using Newton's law of gravitation. In other words, this m produces a gravitational field at point P. So the point Q is a source of gravitational field. If mass m was absent at Q, we would have no field at point P. And similarly, this point capital Q, since it contains a charge small q, it will produce an electric field at point P. So this Q point is also a source of electrostatic field or electric field at point P, and therefore this Q is called source point. And the position vector of Q, which is r prime, is called the source coordinate. This source point produces an effect at point P. The point P where the effect is produced, effect of M, effect of Q, that is effect of mass and effect of charge, is called the field point. So P is the field point because here electrostatic field is produced, gravitational field is produced. P is the field point. And vector r, which is the coordinate of P, is called the field coordinate. So Q is the source point and P is the field point. So Q is the source point. So these are very important terminologies which will be used very widely, frequently in physics. And what is the significance of R then? The significance of vector R is therefore, it is the position vector of field point P with respect to source point. Source point is Q. So this is the significance of this vector R. So let us make a gist. Vector R is the field coordinate, vector r prime is the source coordinate, and vector capital R is the position vector of the field with respect to the source. Let us evaluate capital vector R in terms of Cartesian coordinates. Let us first define what we mean by vector R. This is the origin, these are the coordinate axes x, y, z. Let this be vector R, and let us consider another point and the coordinate of which is vector R prime. Then this is capital vector R. It is directed towards the field point. So this is the field point and it has coordinates x, y and z, while this one is the source point which has coordinates x prime, y prime, z prime. This is the origin. From this triangle law, we have vector R to be R minus R prime. Where vector R is given by and the position vector of the source point is given by it is the primed coordinate x prime, y prime, z prime. So it is clear that vector R will be vector R. So we have to write x cap x plus y cap y plus z cap z minus x cap x prime, y cap y prime and z cap z prime. So what we get is an extremely important and widely used result in physics. So this is vector R. Now this being a vector, it has two parts. One is the scalar part and the other one is the vector part. Our task is to find R and R cap separately. So let us first find scalar R. Now this can be written as under root vector R dot vector R, and this leads to whole under root. So this is the magnitude of capital vector R, and the unit vector R is actually vector R by the scalar R. So we have to copy this result. These are the answers. Let us do a problem. The position vector R of a point changes. The two options are given only in magnitude and in another option it is given that the change is only in direction. Now the question is, what can be said about the point's trajectory? Or locus. Now let us build a coordinate system. This is x-axis, this is y-axis, and this is z-axis. This is the origin O, and let this be the position vector. This distance is say r, and this unit vector be r hat, and let us consider a point P here. This P is the instantaneous position of the particle under consideration. Instantaneous means at time t, at some time t. Now let us move on to option 1, which says that changes occur only in magnitude. Now what is the magnitude? The magnitude is this distance, that is r. So magnitude r changes as per the first option, and the direction remains fixed. So this means that the particle will move along the straight line OP, either along r cap or along minus r cap, and as it moves, the magnitude r, that is distance from the origin, will change. So the trajectory will be clearly a straight line. So the trajectory of the particle will be along r cap, will be the straight line OP. We next come to option 2, according to which the direction changes. Magnitude is fixed. Let us draw the axis. This is the origin. At time t, the particle was here, say, and the direction was r cap, and the magnitude was r. Now after some time, say t prime, the particle comes here, and the position vector is along this direction, which is a different r cap, but the magnitude has to be same as per the question. Again, after some time, say t double prime, the particle comes here at some another point, and the position vector has a direction which is different from the previous directions, a different or a new r cap, but the magnitude has to remain same. So this means that the particle traces a circle. So the trajectory of the particle is circular and the origin is the center. When it is on the circle, at any point on the circle, the magnitude is always r, which is the radius of the circle, but at each and every point the direction of the position vector changes and the particle moves along the circle, means it is always directed along the tangent to the circle. So the trajectory is a circle. So let us complete the problem by writing that the magnitude of position vector is r, direction of motion is along tangent, and the direction of the position vector always changes. It is a general r cap. R cap, this is a new r cap, this is another new r cap, and so on and so forth as it moves along the circle. And the movement might be in the anti-clockwise sense or it might be in the clockwise sense.